we are having Dr. Lubna Luxmi Dhirani from University of Limerick, Ireland. He is going to talk on use cases, challenges, and best practices in implementing digital twins in terms of security issues, security perspectives. Over to Dr. Lubna.
Yeah. So just to ask if my screen is visible to everyone,
Yeah,
and
screen is visible and the voice is very clear.
okay, all right. Thanks for having me on the symposium. I'm Lubna Lakshmi. I'm an associate professor here in University of Limerick, and I'm leading the Catch VR project from here in UL. So today I'll be speaking about challenges and best practices in implementing digital twins from a cybersecurity perspective. But before I start, I would like to thank all the speakers before me who did a fabulous job and made my life easier. So there's less ground for me to cover. Yeah, so said this, let's get started. Just to give a brief introduction, I'm part of two research centers. One is Science Foundation Ireland Lero Research Center for Software. The second one is for Center of Robotics and Intelligent Systems. This is a research center where we do a lot of, marine and manufacturing type industrial-based industrial IoT projects. And one of the projects that we are recently, my colleagues are looking into is advancing offshore underwater applications using a robotic system with robust navigation and virtual supervision capabilities. What this research does, they present a digital twin framework for marine systems using IoT, and this boosts the productivity, efficiency, and safety. They also propose a network topology for remote supervision of multi-vehicle systems that enhances the Ocean Rings Plus interface for 3D interaction and ship ROV anchoring systems. Um, so the overall system supports an autonomous navigation, fault-tolerant control of underwater vehicles, advancing offshore operations from human in the loop to human on the loop, reducing operator stress and cost while improving mission focus. You can find, if you just pop in this title, you'll find a video demo of this research and of the implementations we have done in the research center so far. So you'll have a hands-on things that what we have done in context of digital twin. As a lot of research from our side happens in digital twin happens from the marine side, so I'll be giving an example. So Professor Agatha and the other presenters did speak about the digital twin, but I will give you a different dimension of it, that we're basically connecting the five components over here: a physical dimension converting into a virtual entity, and we need connection, we need data, and we're enabling services using these. Each of these dimensions need to have certain standards in place, certain processes in place to make sure that the whole digital twin environment works more seamlessly. I'll be fleshing it down in the coming slides. So why do we need digital twin? Um, in 2023, we had the IEEE Oceans flagship conference here in Ireland, where we had 7,000 participants coming here, and the majority of the people were looking at digital twin implementations for predictive and conditional monitoring, because 70% of the Earth's surface is covered by water. And a lot of time when you go for real-time experimentation, going into water, that there are weather challenges, you might not get the talk, you do real-time testing and the results don't come optimal. So you have a very limited time period in which you can go in the water, you deploy your equipment and you collect data from there, and then um, you analyze those results and make decisions over that. Digital twin gives us that facility, that edge to do precision monitoring and condition monitoring in the environment, and make evaluate and look at different cases and different scenarios. So it gives us a broader context. Um, and so apart from just cost effectiveness, it also gives us more efficient ways to realize this. So what we do is implement IoT-based sensors and AR/VR wearable technologies inside this type of thing. And so not only besides just detecting, protecting different scenarios, we're also looking at offshore wind pipes, surveillance, mine detection. So there are broader use cases that the digital twin facilitates us with. This is a second example. over here, where we have marine IoT based applications to so if a ship moves on or if an ROV is moving at a certain time period, these are physical security threats. But beside that, we also have to look at the applications that are down there. If the data is being compromised, if the communication is being compromised from the underwater to the surface buoy, if there's a DDoS type of attack or a man in the middle type of attack, or um, that there is any type of you know service disruption happening, that will lead to not only lack of command and control, but also um, number of different losses at that point. So this is where we're looking at, yes, there is an advantage from a sustainability, from an efficiency, from a moving forward perspective. Um, but then there are a number of challenges from a security end here as well. Just to first give you a brief overview, as Professor Agata mentioned, that there is real-time data integration inside this type of environment, and that is the very much the key, because data, if the data, the confidentiality, integrity, or availability of data, if that is exploited, we cannot trust on the twin. We cannot trust on what is actually happening. Are we making the right decisions? Are we going in the right direction? We might be doing absolutely something wrong. So that is one of the key. But how do we build it? That is the first question. An easy example that is demonstrated at the right hand side of the screen. We have AR enabled device, which has a vision system. So when we put the camera on it, it identifies the object, and it recognizes its shape, or markers attached to it, and then and the second stage, what it does, the AR software connects with the 3D digital facsimile of the object in the cloud called a digital twin. Once that happens, the third point that is over here, you can number 3, which is data that is attached, data from sensors of the physical object. It streams towards the twin where that is combined to make a whole analytical perspective of it. Once that is achieved, the software retrieves information such as performance data of the object, instructions, and giving a user a view, a whole view, 3D view of it. And that's the next stage we look into, is to interact with it. You give instructions on that virtual environment, and you see if the real twin, if the real object, physical object, is taking those commands and controls. So kind of merging the real and digital world together. This is the type of environment we are looking into. And what more can we do? What type of exploitations can come here? Now, when we're talking about a digital twin, so it's a whole, as I mentioned in my first diagram, we have the virtual entity, physical entity, we have sensors, we have data, and we have services. Over here, the exploitation can come from the cloud, can be Gen AI based. Um, you know, it can come from sensors. Like sensors are the most they can be compromised very easily. There can be memory corruption, flaws in the IoT device software. They can be exploited using stack-based buffer overflow attacks in their firmware. You can that may lead to hijack their memory, remotely. So when you encrypt the data within the environment, that encryption is not enough. Like this is with GDPR, you would say, or with the new regulations coming, that you encrypt the data that is transmitting. But even when the data is encrypted, when that data, the IoT data, is moving towards the server, it needs to be decrypted by the server, and it reads the data, assesses what's inside it, and then decrypts it again and sends it back again over the network. So when 5G IoT DDoS type of attacks happen, it overwhelms. Because of the DDoS attack, the system is already flooded with messages, and then again with encryption and decryption, it becomes slow, it gets flooded, and it ends up in kind of a downtime scenario. So I have mentioned a paper down here, and this is a research paper in which we have demonstrated a number of different IoT-based attack scenarios. You might find 15 or 20 of the different scenarios, and even used a simulator. So we have used emulated those threat attack scenarios, use simulated data, see what is happening in real time, and then we are using again AI machine learning algorithms to mitigate the Gen AI based threats that are arising in the IoT environment. So, you know, this is just one of them. The others could be weak authentication authorization, access controls, patch management, lack of built-in security, or even, if there are these sensors, they're very sensitive, sometimes with grim, sometimes with dirt, sometimes with other elements, they can be exploited. So the main factor comes here, the reliability. We need to have those ability to identify that whatever the data is being transferred from the sensors to the digital twin, can we rely on that data? Is it authentic? Is it clear? Is it precise? Is it timely? Is there a timestamp attached to it? So in one of the experiments, we identified that the data that was anomalous data that was coming, it had a different timestamp. It had a different frequency of coming as per the normal data sets that were coming in. And that was one of the ways, not all, but one of the ways to identify that this is a malicious data that is, Gen AI based one, or malicious, I would say, rather there. So we have number of regulations coming in the Cybersecurity Act, cybersecurity certifications, Cyber Resilient Act, and even IEEE standards, ISO standards, um, which are focusing, which are strong arming, products and services being developed, specifically the IoT based products developed to mitigate the security issues and to mitigate the risks that these emerging technologies bring inside the environment. So yeah, this is what I've told you is, considering the time, I'm just touching the surface. I've not gone deeper inside this topic. And cybersecurity is definitely like an onion. You need to look into different layers. So just to give you a very high level overview here, you can see there is an perception layer, network layer, cloud and application layer. Over here, we're using temperature and health monitoring sensors. These can be different. You can use any IoT based sensors. They're connected through different mediums going towards processed within the cloud environment, and there is an application layer attached to it. We demonstrated during our research that each of these application layers were exploited to different type of cyber threat scenarios and cyber attacks. So if this is exploited, when you're moving it towards the twin, you can't be actually rely on that data. So you have to make sure that your IoT data is secure, is intact on all of these layers of the perception, network, cloud and application layer. If this is not intact, what goes in the twin, you can't rely on it. um Moving forward towards one of the use case scenarios over here, that this was undergrad project in which a student, he designed a web VR game. He looked at the different security implications, security and privacy inside that. So he conducted two attacks. One was a backdoor attack, and in one he was looking at unauthorized attack. So in the backdoor attack, he used a Unity game and injected cheat buttons inside it, and because of those cheat buttons, he could not only just move ahead inside the levels, but he also had, due to this injection, he could also see or manipulate his core, manipulate things within the gaming environment. The second attack scenario that, he spoofed the API in the environment that gave him unauthorized access to other users' information, their names, their email addresses, and their other personal information, and that was a massive GDPR breach. So we also suggested some mitigation strategies based on the cybersecurity MITRE attack framework, and we mitigated these using the two strategies, which is access control, account use policy mitigation, and privileged account management inside that. Now, when we look at the knowledge graph of a digital twin, what does it give us? It includes connected devices, user access events, application resource usage, and also service health, or we can say precision monitoring and precision of the environment. You can see a user is connected through different applications, share or transfer the data might be transported during different networks, and then so there are multiple points of communications and connections at this point, and there can be multiple point of exploitations as well. So what do we need? We need a cyber twin to it. We need to actually simulate each of the, like one of the examples Professor Agatha showed was of factory floor, the shop floor. And what we do inside for cyber domain, we use cyber range in which we simulate the entire factory, so we can see the flow of data happening within, within the Purgy model, between the IT OT, between the IoT devices. Like, so we have the whole view of from the PLCs, from the SCADA systems coming towards the IT end. What is happening in the whole infrastructure, and we can identify what are the potential points of entry, what could be exploited, what could be bypassed, is the network segmented. Um, so the cyber range gives us helps us in building, simulating real scenarios and testing them in real time as well. And it's also equipped with Gen AI based inputs that enables us to mitigate threats arising via emerging and AI generated malware. Um, Another best practice that is coming here is the European Cyber Resilience Act, that is focusing on security by design, and and specifically towards where you're buying all the IoT manufacturers need to provide detailed information and have to go through a certification, have to go through auditing and risk assessment, just to tell that the products that involve digital components are secure, are reliant, have security and privacy and design in place. Beside that, there are a few other standards which I'll be speaking about later. We need to assess the standards and risk. So each industry, each organization is different. So one model doesn't fit all. So by designing the cybersecurity blueprint for one company where they had a physical factory and then they had a factory in a box, there were two different strategies that need to be aligned, because the physical factory was connected with um, Ethernet. They had Ethernet connections, whereas the factory on a part that needed to be connected with TSN Ethernet, we needed to have a Wi-Fi 6 connection and also through 5G connection, because that's a portable factory. It has universal machines involved. It's connected to the cloud, and basically it needs to be it should be adaptable. So when we ship the factory in a different jurisdiction, it should be able to work in different setups, either remote or within a city infrastructure. So we need to look at these gaps, both technical and from the standards and security perspective, and build it. What I meant by the onion layers, so this is what would give you a better insight. Let's say this is what our critical asset is. This is what is business important to our business, and we need to protect our critical asset. Like this can be our storage, this can be our manufacturing environment, this can be our PLCs, anything that is critical for your operations to go running. We need to look at data security. We need to look at application security, human level of security, which is one of the ones. This is why we're focusing on upskilling, endpoint security, network security, and perimeter. So there are 7 different layers of security that here we're looking on. And if an exploitation happens at any of these points, the data can be compromised. So our critical assets can be compromised. So it's easier said than done. Now, if we move towards the diagram top here, where we have AI, like it's data and AI enabled. So we need to build that intelligence within our digital twin. Um, to have condition monitoring and predictive maintenance, and IoTs are the sensing environment. But if any of these things are compromised, the digital twin is compromised. So these are very, very important, very core. You need to make sure that these layers are intact. If these are not intact, the twin will be compromised. In this is a real example of a cyber range. What does a cyber range? As I said, that we simulate the same real environment. So this is basically a physical cobot arm, and this is what we have simulated within our cyber range. And whatever data is being transferred here, we use the same, we do the same, build the same threat scenarios, run an attack over it, and then see what the impact happened, what was compromised, learn from it, and then build on top of it. So this gives us an edge to make changes in our real environment to protect our real factory from what is happening. So this is something we have within our university. We have cyber range license, and we have developed a number of scenarios um, for manufacturing, for pharmaceutical, for different type of even attacks happening in that shop floor, um, to demonstrate the risks. So just few closing thoughts. I'm aware of the time coming on here. Um, Yes, digital twin, it does give us a sustainable edge, optimizing, we can optimize, monitor, reduced e-waste, and that's one of the major, goal for enhancing circular economy and net zero thing that is going on, and also looking at the whole, making our supply chain more sustainable. So in that context, there's also another thing that has come in place, which is the DPP, Digital Product Passport. So from the start, from the point that you take in raw materials till the point a product reaches the end user. So let's say we take an Adidas shoe. So the time the raw material came in, every single thing inside the supply chain, the DPP has a QR code. So when the end user, when the product is ready and the manufacturer is about to ship it and he scans the QR code, it will give the whole supply chain. Where was it bought from? Who was involved? Where was it manufactured? How was it transported? Who were involved in transporting it? So let's consider a digital product at this end. Let's take IoT devices or a vision system. It enhances our security throughout the supply chain. And if an exploitation happens, we know it's a third party exploitation. We know that it's a hardware exploitation or a software exploitation, or maybe um, something else went wrong during the whole supply chain. So these are the type of things that will also apply towards when we're looking at the digital twin. Um, Other things that we're looking at is NIS2T, which is Network and Information Security Directive, and that applies to all manufacturing and production and all type of critical infrastructures, smart grids, water facilities, telecommunications, railways, all big infrastructures. Um, so to make sure that to mitigate the emerging and advanced threats that are arising inside, our environment. Beside that, there are the other regulations like Data Governance Act, Data Act, GDPR Act, and these acts are looking at making sure that the confidentiality, integrity, and availability of data is intact. That's basically GDPR, making sure that the personal data is secure intact, whereas the Data Act and Governance Act, these look at few other components where data will be shared across, like non-personal data will be shared with industries of that manufacture similar products and services. So these things are coming in place to make sure security is intact. However, in whatever forms data is being shared, also high level of um, uh, baseline securities have been implemented in different European countries by their national cybersecurity centers. There have been cybersecurity certifications implemented to make sure all the manufacturers or the implementers of these environments, they're compliant with that. So these are some of the ways, standards, regulations, auditing, looking at the technical perspective, looking at the cyber threat scenarios, looking into cyber range to test um, the threat scenarios in real time. These are some of the ways to secure the environment. And again, we spoke about the potential IoT exploitations. Metaverse is pretty new. I would say it's again inside. If you look at the European Union website, it's still in the infant stage, and um, they have four different goals that they had announced for building trust and transparency inside the metaverse, and they're looking into different themes of building this. So I think this is an ongoing effort, and what we're doing here inside this project is upscaling it from different perspective. Each of the presenters today gave a different dimension about what what we have done so far, where we are, and what are the ongoing challenges are. So yeah, and if you're looking at different novel type of threats that I would also be concerned about is inside the digital twin would be the quantum sensing, because that is going to change a lot of things within the production and manufacturing type of environments. And this is something we are not prepared about. So it's we don't know the scale at which this threat is coming. So it's very hard to assess the impact of it and in what ways it can change the dimension. Just to give an example, very recently, a new Microsoft rolled on a new update, and in that, what happened? There was a university. I won't name. It's in Europe, and they rolled out that update, and as a result, the students had access to everything within the university, from exam sheets to results to academic registry to everything. So what that update did is it neutralized the access controls and privileged access management. And as a result, everybody has access to everything. The university had to take down their systems for 2 days to undo that change. And then they segmented all their network. Generally, we use segmented. So, that when you roll out a new policy, the system would identify that this is who has access to what. And so these are the type of risks we didn't know could happen. So this could happen to one or many of the universities or many of the industries out there. So there are scenarios that we're still not aware of and not prepared of in terms of quantum machine learning and quantum sensing. And moving forward, this is good news for me because I have got a Irish Research Council funding, and this is a postdoc project that in which we'll be building marine IoT cyber resilience and sustainability in underwater wireless sensor networks using digital twin. And this is starting from September this year. We're also working on an ongoing research paper down there, and this paper, it outlines the scope of digital twin and its role in underwater marine ecosystem. Also deep dives inside the security challenges in marine IoT applications. We also speak more comprehensively about the standards, regulations, and legal aspects of the digital twin. And we also demonstrate the marine digital twin implementation. So this is something that when it's published, I will surely share the paper. And that's me. If you want to contact me for collaboration, that's my email address, and that's me.
Okay, thank you very much, Dr. Lubna Luxmi Dhirani, for sharing huge information about use cases.